guy.
Hello everyone. Today my seminar is about the introduction to machine learning and PyTorch, especially the deep learning. And this is a guide to the getting started with AI. My name is Mingzhi. Okay. This is an overview of my presentation. At first, it's an introduction to the deep learning, and then the introduction to the PyTorch. And at last, there's some core components of the PyTorch. And I will also provide some codes to implement the deep learning in the framework of PyTorch. It is a T5 and also a simple BSTM. And at first, it's about what is deep learning. At first, I have to say that deep learning is a part of the machine learning, and the machine learning is a part of the artificial intelligence. The artificial intelligence allows machines to be able to carry out tasks in a way that we would consider smart. So as we say, this is a quite broad concept. And the machine learning is a subset of AI that will enable the machines to learn from data and then use algorithms to generalize to unseen data. Yes, so that it can perform tasks without being explicitly programmed for those specific outcomes. And actually, the statistic models, I think we are quite familiar with, is also a part aspect of the machine learning. And the deep learning, it is a further subset of ML. And the symbol of it is utilizing the neural networks with many layers. And it enables to learning from the vast amounts of data and mimicking the way humans can certain kind of the knowledge. And there's also another thing that's quite similar to the human's brain, that is like we don't know how the information flows or processed in our brain or the cerebral cortex. We don't know how the deep learning neural networks works. I mean, we know the architecture of the neural network, but we don't know why it works. Yeah, we cannot explain it like the statistic models. So to some extent, it is like a black box. And then why we use the deep learning? First is that it has a lot of advertisement, and it performs much better than the traditional methods in many fields, like the image recognition and also the natural language processing, and also the speech recognition and the prediction of protein structure. The impact is that thanks to the deep learning, for example, the medical image can be analyzed much better with higher accuracy, and assisting in detecting diseases early and saving lives. And also the search engines like Google or Bing also significantly improved in functionality and efficiency with the help of the deep learning models. And so that these search engines can be more personalized for the users, and they can do better in understanding the user intent as well as improving the search relevance. Yeah, at last, there's some famous applications of the deep learning, like the AlphaFold tool, which is used to predicting the protein structure, and also the ChatGPT, which is quite famous, that can generalize the text very well, and also the Sora just come out several days ago. It can generate the video just based on the text, and it has a very good quality and stability, and it can be as long as 1 minute. This is, even though 1 minute is not long for maybe movie, but it's much better than the formal models. And then this is some important concepts in the deep learning. The neurons is basic building blocks of the neural networks. It is inspired by biological neurons in the brain, and also the neural networks. It comprises layers of neurons, and each layer also has multiple neurons that can transmit signals from the input, and then learn to make predictions of classifications. And also the activation functions. Every neuron could have an activation function. It could be like ILU or sigmoid or softmax. And it can help determine or say update the output of the neural network nodes. And then the loss function. This is quite important. After we get the output of the model, we can use the loss function to compare it with actual data, or we can say the label, yes, so that it can measure the loss. The mean squared error is used as a loss function for the regression tasks, as we used in the statistics models, and also the cross entropy for the classification tasks. And then the back propagation. This is a quite important part in the machine learning or the deep learning. And I think, this is used to update the model's weights effectively. That is, in the model, there's a lot of weight metrics that is used to. I'm sorry. Backpropagation is a very important part of the deep learning, and it is used to update the model's weight metrics, and the weight matrix is used to transform the information, the data from one layer of neural nodes to the next layer of neural nodes. Yeah. At last, when we calculate, when we have the loss, we will calculate the gradients of the loss with respect to the weights. Yeah, there's a lot of weights, could be thousands of billions of them. And then we use backpropagation to update those weights according to the gradients. And we also use the optimizer to select which weights will be updated. Yeah, not all the weights should be updated in one step. And then it's a PyTorch. It is an open source machine learning library. It is developed by the Facebook's AI research lab. It is primarily focused on the deep learning and artificial intelligence projects. And it is originated from PyTorch, a scientific computing framework, and was released in 2017. It quickly gained popularity because of its ease of use, flexibility, and the dynamic computational graph approach. And it is widely adopted in both academia and industry for research and development nowadays. And nowadays, it is quite renowned for its significant roles in facilitating cutting-edge AI research in academia, and contributing to the advancement in fields such as natural language processing or computer vision or reinforced learning. And in the industry, it is also used by a lot of companies for developing models for many aims, such as fraud detection or content recommendation systems. Actually, nowadays, it is basically the mainstream in the academia. Yeah, most of the AI researchers use PyTorch as its framework. When it comes to the industry, it's not that popular, not that mainstream, but it has a bigger and bigger proportion because that many students learn the AI through the PyTorch, and many companies, especially the small companies, have to adapt to that. For example, the ChatGPT was developed with PyTorch, in the OpenAI, because this is a quite new company, even though now it is not small again anymore. Then There's some key features of it. It uses dynamic computation graphs. It is not like static graphs in other frameworks like TensorFlow, and it uses this to allow for more flexibility in building complex models. This feature makes the PyTorch intuitive and adaptive, suiting the needs of research and developers for rapid prototyping and testing. With help of it, to write the code to build the model is much easier, and it's also easier to find the bug. And also, it has a very good integration with the GPU acceleration. It provides seamless support for the CUDA, which is the GPU framework of the NVIDIA, to leverage the GPU acceleration. It can significantly speed up computations necessary for large-scale neural networks. And it also has a very rich ecosystems. It compresses libraries such as touch visions for image processing, or touch text, and also touch audios for text and the audio processing. And this ecosystem simplifies the development process and enhances the library's functionality. And it also includes comprehensive tools for deep learning, such as PyTorch Lightning for simplifying the boilerplate code, and also the TensorBoard for visualization. And also, with help of them, it can facilitate efficient and streamless development process. There's other frameworks. Maybe except PyTorch, the most famous one is TensorFlow. It is developed by Google, and it is known for its robust production capabilities and intensive ecosystems. Yeah, it is quite popular in the industry. While TensorFlow uses static computation graphs by default, and compared to this, the dynamic nature in the PyTorch is often preferred for research and development that requires flexibilities, especially in the academia and some new small companies. And also Keras. It is a high-level neural networks API running on top of the TensorFlow, and it is designed for the easy and fast prototyping. While Keras simplifies model development, the PyTorch provides a more granular level of control over model design, which is quite helpful for custom model architectures. Yeah. When it comes to comparison, the PyTorch is also preferred because of its simplicity and ease of use, especially when it comes to debugging and dynamic computation graphs. And TensorFlow uses the static graph capabilities. In many cases, it provides better computation efficiency. And Keras, it is a part of the TensorFlow ecosystem, and it focuses on the accessibility, but lacks the low-level control desired by the researchers. Then is the tensors in the PyTorch. It is the key data type in the PyTorch. Basically, every things like the arrays or the vectors or the metrics are in this format. And this is a simple example of it. It is quite similar with the NumPy array or to some extent the list in the Python, or the vector in the R. And then the autograd system. This is the important part of the PyTorch, and it can automatically it powers the neural network training and automates the computation of backwards passes in the neural networks. I mean the back propagation, as I mentioned before. Yeah, it can enable the automatic calculation of gradients for tensors and model parameters, and essential for the optimization process, and facilitates complex computations in the dynamic computational graphs, and also simplifies the implementation of back propagation through its automatic differentiation capabilities. the touch.nn. This is the core module of the touch. Yeah, it provides the building blocks for creating neural networks. For example, usually the neural networks includes the activation functions or the full connection layer, the linear, that is a linear function, and also the CNN, convolutional neural network or recurrent neural network. Yeah, these functions can be easily called in the touch.nn, and yeah, it is quite easy to use. So people don't have to manually create the whole neural network. Just call the functions inside the touch.nn is enough. Yeah, and it also supports the custom layers for specialized needs, and it will provide utilities for weight matrix initiation and other model parameter management. Yeah, that is, for example, at the beginning, the weight matrix should not be all zero. Usually, it's not good to be all zero, and we can use the touch.nn to initialize it with some values. Yeah, usually based on the experience. And also the optimizer and the loss functions. This is crucial for training neural networks and guiding the updates of model weights based on the output of the loss functions. Loss functions, as I mentioned before, it qualified the difference between the model predictions that the outcomes based on generated by the model and also the actual data, the label. Yeah. Just like when we use the statistic models, the output of the for example, the linear regression and also the labels that we have in the real data. And the common examples of the loss functions are MSE for the regression text and the cross entropy for the classification. Then the optimizers, it could be SGD or ADAM. Yeah, it can effectively adjust the model weights to minimize the loss. Yeah, this is because we didn't directly adjust the weights in the model based on the gradients of the loss function to it and the learning rate. There could be some adjustment and also some selection of the weight, and we also select some part of the weight to update it. And this is connected by the optimizers. And yeah, as I mentioned, the PyTorch is a very good integration with the GPU acceleration, especially with the CUDA. It is NVIDIA's parallel computing platform, enabling the dramatic increases in the computing performance by using the power of GPUs. And the key points is that the simple API it has a very simple API to move the tensors or the model between the CPU and the GPU. And it also enables faster model training on inference times. It is also essential for working with large data sets and complex data models because it will require a lot of computation. Yeah, and the GPU can significantly increase the speed. Then is the custom data sets and the data loader. Touch.util start data provides utilities for loading data, making it easier to feed data into models for training and inference. Yeah. Well, that is every time the model didn't train on all the data. It is trained batch by batch. Yeah. We only, for example, there's 1,000 texts in a data set, 1,000 sentences in a data set. And every time we select one batch, like 32 sentences to do the training. and also do the back propagations on those batch, on this batch. Yeah, and the data loader can help us easily do this. It can help us to do the training batch by batch. It wraps a data set and provides a iterable traverse over the data set, usually batch by batch. And with a support for batching, sampling, shuffling, and multi-process data loading. And this is quite important for the efficient training, especially when dealing with the large data sets that we cannot fit all the data into the memory. We can fit using the data loader to put it into the memory batch by batch, and leave others still in the disk. Then it is the transfer learning and the pre-trained models. This is a very important strategy when doing the deep learning to use it in our own scenario. That is, PyTorch offers access to a wide range of pre-trained models, such as the VGG, ResNet, or BERT, and through its touch vision, the touch audio, and the touch text libraries. These models are have already trained on very large data sets, like the ImageNet. Yeah, those models has been very mature and has been very versatile and useful. But sometimes we want to use in our own scenario, in our own text, in a specific scenario, and we want to use our own data set for that text to improve it, to fine tune it. Yeah. So with the help of the pre-trained models, we don't need to train on that much data or spend that much time or resources. Yeah. So this is quite helpful. And sometimes based on the pre-trained model, we train the new data set only on the final layers, but sometimes we can also train it on the entire model or significant portion of the model on the new data set. Yeah, this is based on how your task is different from the data set that the pre-trained model is based on, and also how much time and resource you have. Yeah. Then is the distributed training and PyTorch Lightning. The distributed training is quite important nowadays because the model and the data set is becoming bigger and bigger. It is basically impossible to train the big model on only one node or one machine. Yeah, it should be trained across multiple GPUs and nodes. So the touch that distributed can significantly help this. It can support various methods for parallelism and including the data and the model parallel. Yeah, and then the Lightning. It is a lightweight wrapper around PyTorch, and it can simplify a lot of boilerplate code for the training loops and other steps. And also, it will enable the cleaner and more modular code, and making advanced techniques like distributed training more accessible, more easy to use. Before, well, I will introduce it and then show the code, show some code for the PyTorch and the deep learning, because I cannot switch between these codes easily. Yeah, the PyTorch has a very robust ecosystems. It includes not only the core library, but also a rich collections of the tools and the libraries. Yeah, so that it can deal with the texts ranging from the computer vision to natural language processing using the touch video or touch audio and the touch image. And it also has the so that it will be more easy to use. The PyTorch community is supported by an intensive network of the forums, user groups, and discussion channels, including the official PyTorch discussion forums and Stack Overflow and Reddit. This can help the knowledge to share and help people to troubleshoot when we have problems with the codes. And people can collectively solve the problems. And when it comes to the educational resources, the PyTorch itself has a wealth of the tutorials of the documentations, including the official PyTorch tutorials. But we can also learn it on the Coursera or the Udacities. They are very helpful. And of course, the USA also provides some courses for it. When it comes to the future of the PyTorch, it has a continuous innovation. It is continuously evolve and become better and better. And it has a growing adoption in industry and academia. Its flexibility, performance, and ease of use has led to its growing adoption for the research projects, and also in the commercial applications and educational purposes. Its dynamic nature makes it particularly suited for rapid prototyping and experimentation. This is a key factor in why it is so widespread, especially in the academia. And also, the future of the PyTorch also includes deeper integration with the cloud service and GPUs and other AI systems. This is because it will require a lot of resource to conduct the training for the models. So do it on the GPU and the cloud service is very important. And this will help to make it deployed at scale and in production environments. And collaborations with hardware manufacturers for optimize the performance and with academic institutions for cutting-edge research are also essential in this roadmap. This is important of the PyTorch.
Can you make the font bigger?
Way bigger.
Like command plus.
No.
It's not responding to that. There we go, that works. Thank you.
This model is T5. It is not as powerful as maybe ChatGPT or GPT-3, but when it released in 2020, just several months before the GPT-3, it is the best. And what's more, it is totally open source, not like the GPT-3. And it can be easily accessed through the libraries. And you can do the transport training on it. Here, at first, we load the model. This is a Google T5, small. It is developed by Google, and it has a different version of it. Small has much less number of the parameters, so it's easier to train. It requires much less computation resource. At first we load this pre-trained model, and also the tokenizer. It is used to embed the text. That is, for example, a sentence. It is compressed. It has a lot of multiple words, and the tokenizer will convert it to a two-dimension tensor array. Two-dimension array in the format of tensor. And then we just do some process of data. And the important part is here. As I said, we do the training batch by batch by batch. And at first, we use the model to do the prediction based on the batch of the input data. Yeah, we calculate the output of the model, basically. Then we get the logics of the model, of the outputs. This is just a simple transformation. Then we should calculate the loss. Yeah. The loss, we use this to measure the loss between the output and the label, the actual data. And then, yeah, as I said, thanks to the outgrad system, to do the back propagation is very easy in the PyTorch. Just one line of code is enough. Yeah. This will initiate the backward pass, so that it will calculate the gradients for the loss with respect to the weights. Then we will use the optimizer to update the weights, and also the learn rate scheduler. The learn rate will determine how much or to which extent, to which scale we update the weight. That is, we will step by step update the weight until the converge, and the learning rate will determine at each step how much it will be updated, how much it will be changed based on the gradient. Then we have to use a zero grad to reset the gradients to 0. Yeah. This is for the next step of the training. And this is just used to update the progress bar. Yeah. So it is quite easy to train our own model based on the pre-trained T5 model. Yeah, this is a simple T5 file.
Can I ask a quick question?
Okay.
If you just scroll back up, you have 2 for loops, and I'm not clear what they're representing. What are you iterating over? The batch and the epoch loops?
Yeah. The epoch means how many times it will traverse all the data. And in the second one, in the one time traverse of the whole data, it will be conducted batch by batch. Every time, for example, the whole data set has 1,000 sentences. And we will do it batch by batch. One time we only do the training on only one batch, like 32 sentences. We don't do the training on all the sentences.
Thank you.
Thanks. And also, and in this case, we don't have to do some granular control of the model. It is to pre-train, and because it has maybe billions of the parameters and millions of the activation function or the full connection layer, we cannot adjust them one by one manually. Yeah. By the way,
so rather than run a set number of epochs, can you set it to keep going until it reaches a certain minimum change in the loss function?
Yes. Actually, there's a step here that it will every time after every epoch it will save the it will save the model and also save the loss. And we will, after we conducted maybe 400 epochs, we will look into them and find that maybe at the 300 times of epoch, it will reach the minimum loss, and we will select that model.
can you, I mean, if you set it for 400 epochs,
Yeah,
it's gonna run 400
yeah,
epochs, right?
Yeah.
Is there a way to say, well, if we've kind of gotten to the minimum loss at 200, let's stop
Yeah.
the looping?
yeah. This is because that when the number of epochs going, the minimum loss will at first go down and then go up in the test data set. Yeah, but we will set the number of epochs to a number that is definitely over the minimum loss point. Yeah, and we save for every epoch, we will save that model and save the loss. And after all the epochs, we will choose one epoch with least
And then,
loss.
Okay.
Yeah.
all right,
I think Jim's asking a different question, which is, can you save it based on some other criterion? And I think, for example, you've got the loss stored as the model as part of the model save, right? So you could write, rather than doing a for loop, you could do a while loop until the loss changes by a certain amount or gets to a certain value, if you prefer to do it that way, couldn't you?
Yeah, that is also one method, and yeah, that is also one way to do it. And here it just wants to get the minimum loss possible. Yeah, not just a loss under certain criteria. So it's just a different strategy.
This one doesn't sound like it's set up to be monotonic, so you're just picking at the end,
Yeah,
which iteration
yeah,
was your best fit.
yes.
If I can say something, one thing that people do is what is called early stopping, which is as just loss function is going down, 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 but it goes down and up. But if you can say that if in 10 times, so in 10 iterations, in 10 epochs, it has not gone down, then you stop. That's called early stopping. I'm not sure how do you say it in PyTorch because I use TensorFlow, but I'm sure there's a way of saying that called early stopping, which is like you say, I'm going to run 400 epochs, but if my loss function doesn't decrease for 10 epochs in a row, then I'll stop and I just keep the last model.
Then we will set the number of epochs to a number that is so big that definitely it will go up before this epoch, before the number of epochs.
Well, okay, let me maybe ask it as a question as opposed to a statement. How do you do early stopping in this framework? Early stopping is the idea that if the
it don't have early stop. It don't have early stopping. It will always run the number of epochs.
Okay, there has to be a way of doing early stopping, but
I think you'd have
Sounds
to,
like-
you'd have to do what Paul
you
said.
just break it. You just break. Okay, it's just a
Use
for
while
loop
loop
in
or something.
no,
Yeah.
I guess it's a for loop in Python. So I guess if you keep tracking how many times the loss goes down, I mean, you can just break out of this loop under some condition.
Yeah.
So, and the thing is that the loss, you don't know what the value of the loss is the right one, but what you can do is like, if I keep optimizing and I keep optimizing and after 10 times my loss doesn't improve, doesn't go down, then I can stop. So you can just see you can count how many times the loss actually improves. And if it doesn't improve for 10 times, then you break out of the loop. That's how you would do it.
But is that a tuning parameter
Yeah,
that
that is-
improves your loss? Or is it just repeated cross-validation where you're just repeating your splits and your random sampling and then there's no monotonicity in the results?
Put my
Mm.
I'm talking.
Yeah. Actually, even though that it have 10 times that it didn't change a lot, it could be go down again because that 10 times maybe lead to some local optimization, and it is still possible that the optimizer can help the model jump out of that trap of local optimization and keep go down.
Answer your
Yeah.
question. Yeah. How many epochs you would go? So it's like 10 epochs or 5 epochs, or that's a hybrid parameter. Because I mean, the loss goes down, up and down. I mean, it goes down generally, but it still has some fluctuations. But then if it doesn't keep improving because at some point it begins to go up, then you want to stop. You want to keep going because maybe you're overfitting. or
I
something?
think this is based on the experience, and we will set it to a big enough number so that it will include the minimum epoch, the epoch that gets the minimum loss. Yeah, we have to set it big enough.
Actually, sorry, when I said this early stopping, you are doing the early stopping with a validation set. So you're testing if the performance and the validation set doesn't
Oh,
go up. So, but anyway, this is your talk. Sorry, I shouldn't really talk here.
the training set, the validation set, and the evaluate set and the validation set are packaged in the data loader, and it will connect it automatically. It will yeah, it is the validation set and the evaluation set is different. Do you mean that only have one evaluation set will lead to some overfit? Do you mean this? It has 3 different sets. That is update the model using the evaluation set, and calculate the loss using the validation set.
I have maybe a different question. I was thinking about ways that you could show us like this model. Are there tools for sort of like explainable AI or ways to investigate what this model is doing besides just like inspecting the loss function at the end, the loss at the end? Are there easy tools for that built in?
Do you mean explain the structure of the model?
It's just trying to understand what the model is doing. Are there built-in tools for understanding what the model is doing?
Actually, when it comes to deep learning models, it is quite hard to understand the structure, and it could be very big, and basically people don't know why it works. Not like the statistical models.
That's the very settling part of the whole thing.
Yeah.
It works, but why?
I have just a really simple question. Is it the same batches every time through, or are you re-splitting the data into different batches?
There's a resampling.
Okay.
Yeah, in the data loader. And when it comes to some much simpler model like the RNN, BRCM RNN, we can do some granular controls.
Can you make it bigger?
Yeah, we have like 5 minutes or,
Yeah.
4 minutes, 3 minutes. So what's different about this model? Did you tell us the data? Is this a text mining question?
Hmm?
Are you doing text mining with these learning models?
This is do the classification based on the sentence, based on the sentence.
Sentences.
Yeah, classification the comments into different favor level of the customer. And yeah, here is the LCM and we can specifically define the FC level, the full connection level, before and after the RNN. And also we can set the activation function for that RNN, and also the dropout. And yeah, here is also combined with CNN, the convolutional neural network function model. Yeah. Anyway, for this much simpler models, we can have more controls over it, and it is possible to do it because you don't have that much number of parameters and not that much number of not that many number of the activation function or the full connection layer. Yeah. Yeah, this is how the PyTorch provided for the granular control, low level control. Okay.
Great, so the comment in the chat was about maybe the lightning tools for PyTorch, allowing this early stopping. So the question that came up early maybe it's allowed in that lightning tools.
touch that lightning.
No, well, it's in the chat for later. I'm just sharing with people in the room. You don't have to go back to it. We can have questions.
Any questions?
I have a technical question about the way the learning model works, which is, it might be deeper than we want to go, but the backward learning step in which you're calculating derivatives with respect to all of the parameters of the model, I assume, sounds incredibly computationally intensive. And I just wonder whether people always do it that way, or do sometimes you just look at partial derivatives with respect to a subset of the parameters and optimize with respect to that subset in one step and a different subset in a different step. I mean, how expensive is that step? The calculation of derivatives, how difficult is it, and how is much time spent on trying to make that more efficient or avoid that complexity somehow?
Do you mean owning? Do you mean?
Well, let me ask a different question. So, where do you spend the bulk of the time when you're running these algorithms? Is it in that backward step when you're optimizing with using the gradient?
It could take a lot of time, especially when the model is big. For example, for the bird, one batch could take half hours. It also depends on how powerful your machine is.
Of course, yeah. So when the model is big and that starts to break down, right? When that starts to grind to a halt, what do people do?
Actually, I'm not that familiar with how they do. I think they will do some specific process of the parallel. I mean, parallel over different nodes, and there could be some. I'm not that familiar with this part for the concurrent part, but there should be some mechanism to do it for parallel for the very big models.
Thanks.
Like the ChatGPT. Yeah, it's also not open source for that ChatGPT.
Any short last question? Just another minute, or we're done. That was lovely.
Okay. Thanks.
All right.